Hmm. Hello, everyone. This is Sunil Kuniseti. I'm a senior director in Oracle IoT Cloud Service team. I'm going to talk about how we leverage Oracle NoSQL. What are the great features we used in IoT and how NoSQL contributed to our success. Let's briefly talk about IoT before we go into the details, right? I think most of you know about IoT. IoT stands for Internet of Things. It's originally coined in 2000s, but it started becoming more famous, more popular in the last 2 3 years for various reasons, right? For better connectivity, much better big data platforms that we have to leverage the data that we get. The cost has reduced significantly for the devices, sensors, and overall business value. So what is IoT? It is the network of physical objects. Right? Essentially, all the smart things, the smart devices, Fitbits, webcams, cameras, sensors, everything is connected, right? The power of the hyper connectivity, we can do many things. The monitoring, proactive actions, right? Improved experience, right? We'll talk about some of the specific use cases later on, right? And it's in a massive scale compared to Internet of People, right? I think just last week, Gartner came up with 100 billion things will be connected by 2025, right? Some even the conservative numbers has put to 20 billion by 2020, right? So we see a lot of potential there, and it's a very disruptive technologies, right? What they say is mobile, cloud, big data, IoT is the next in the trend of the new disruptive technologies we are seeing. So why does it matter? Why do we need to pay attention to that, right? With IoT, we get huge amount of data and information, right? And that we can make important decisions, right? Right? We can pivot and make important uh, prescriptive decisions based on the whole data, right? With IoT, there's huge amount of volume. As we talked about the number of sensors, right? They're not in millions anymore, right? It's like billions of data devices. The amount of data they'll be sending is humongous, easily terabytes of data per weeks and months of days. Not just the volume of devices, but the velocity in which they're sending, right? Unlike previously where they used to send days and hours, now it's seconds and milliseconds. These devices keep sending us data in seconds and milliseconds, different varieties of data, right? Each sensor has their own type of data, so they'll be sending their message in different formats and much more veracity, right? Much more accurate, much more appropriate data and all that one. So with this, right, huge potential, with more volume data, with more accuracy, we can do much better, right? We can solve the last mile connectivity problem, right? Which can enable us to do better automation, right? The biggest problem we have today is the disconnect between the OT and IT, right? On the operational things, we have all these devices and machines, and IT, we have all these enterprise applications. What IoT does is bridge the gap between OT and IT. That enables better automation, right? We can do things more proactively. There's a massive investment in IoT from all the large companies, right? And so this is a pictorial overview that was given by the IoT World Forum. If you look at the bottom of the stack, we have all the physical devices, the things, the so-called things in IoT, right? And they use different connectivity protocols: LTE, Bluetooth, Zigbee, MQTT, Wi-Fi, right? So either they can talk to the server, IoT server directly, or in most cases they go through via some kind of a gateways, edge computing. Once we have the data, right, then we need to abstract the data, right? We need to aggregate the data, we need to do analysis, we need to do prediction, forecasting, anomalies on the data, right? And we are building custom applications that can leverage and which are very domain specific. And on the top of the stack, we have all this collaboration and processes and all that one, right? So we'll talk about that, how IoT, Oracle IoT Cloud Service, has a play in each of this layer. So let's shift gear and talk about Oracle IoT Cloud Service for a minute before we talk about the NoSQL value add. If you look at the world, right, there's a huge paradigm shift that's happening across every shift of life, right? On the maintenance side, we used to fix things when they get break, and then we started getting better, we started scheduling things. But to be more efficient, we need to prevent, predict, and prescribe, right? We need to first of all predict when the issue is going to happen, right? We need to, based on the prediction analysis, and to top it off, we need to prescribe. Okay, we know it's going to happen now. How do we fix it? Can we prevent it? What are all the possible solutions and all that one? Right? That's a big thing, and for that you need much accurate data, right? Real-time data as well as accurate data. In the ownership, in the consumption model, there's a shift from ownership to as a service, right? Instead of being you owning it, you just want to lease something as a service for the consumption period. The same thing's happening in the analytics model, right? In the old days, we used to accumulate the data, and then we used to run analysis, data mining, SaaS on a post-operation basis. What we should do is, there's a shift in industry, right? Instead of doing that static analysis, we are doing more real-time big data analytics based on the whole Lambda architecture, streaming analytics, and all that one. Uh, and from a service model, instead of a central service, it's all self-service. Whenever you want, you can log on to the thing and leverage the service. How does IoT service, Oracle IoT Cloud Service, going to help you in this one, right? So we have a very robust platform to start with, right? The platform can do the device virtualization, gateways. It has basic modeling aspects, application data model, right? Stream analytics and all that. Well and good, but to leverage it and build vertical applications, it's time consuming, right? And it takes probably 6 to 9 months of implementation time. To cut short that, to reduce the TCO, right? One of the things that we are doing is building smart applications on top of the IoT platform, right? We call this packaged domain specific applications, right? These applications are very LOB specific, right? And all these algorithms and anomalies that were very LOB specific and all that one. And as part of that, we certify the gateways and devices. So overall, it cuts the adoption time, right? With that will take the 3x faster time to value. So here are some of the IoT applications that we are building in the first phase, right? We have asset monitoring, production monitoring, fleet monitoring, and connected workers. Right. Let's talk about a couple of them just to give an idea of how LOB specific, domain specific they are. Asset monitoring, as the name implies, the goal is to monitor the assets, right? The health of the asset, the utilization of the asset, and more importantly, the location of the asset, right? We want to start monitoring the asset whenever the asset leaves the desired location, you want to be notified. So the basic premise of asset monitoring can be leveraged by this vertical app. Next is the production monitoring, right? The goal of this app is to monitor your factory, right? You want to look at all your machines in the factory, whether they are up to the mark, what is their production capabilities, do they meet the production output they're supposed to meet, and if machine goes down, how does it impact the overall production output, and whether we can proactively replace the machine in a very short time and see whether we can meet the production output, right? So the whole production equipment monitoring and prognostics can be leveraged by this app. and the other apps that will be working out fleet monitoring and connected workers. So if you look at the overall IoT cloud service, we have the IoT platform at the bottom of the stack with the whole premise of connect, analyze, and integrate. Connect with the devices, analyze the data, integrate with the enterprise applications and other cloud services. On top of it, we're building the so-called mini app SaaS, the asset monitoring, the fleet monitoring, production monitoring. We just talked about that, right? And on top of it, at the high level, we have this cross application collaborations, right? So if you go back to the if you go back to this applications, right? So this is where we are building our mini apps and all that one, right? The IoT platform gives you till number 5, right? So we started doing number 6, which is building the applications, and later on we'll be working on much more cross application collaborations called voice of factory application. So this, in a nutshell, is Oracle IoT Cloud Service, right? We have the platform, we have the mini apps, we have this high-level cross vertical solutions, voice of factory, reliable centered maintenance, right? In addition to that, we provide various integration with Oracle Cloud Service, mobile cloud service, BI, storage, SOA cloud service, etc. So I think hopefully that gives a good overview of IoT, Oracle IoT Cloud Service, and that with that we can segue into how we used Oracle NoSQL. So if you look at in general, the advantage of a NoSQL database is the main thing is they're complete horizontally scalable, right? You can easily add a shard. NoSQL can automatically scale out and balance across shards, right? That's a huge feature with IoT, as we talked about that. The amount of data, the velocity of the data is sort of unpredictable, right? So we can start with the baseline and keep adding shards whenever the capacity reaches a threshold. So we should be able to have a platform that can horizontally scale, right, without any downtime, with zero downtime, right? So this is one of the biggest feature that we got from NoSQL compared to the databases and all that one, right? Ability to scale with zero downtime. And the data model that NoSQL provides is very simple. It's a simple key value that will allow us to support a variety of data. As we saw earlier with IoT, the data that we get is not the same from different devices and sensors. So we should be able to adapt and ability to support multiple varieties of data, right? So we cannot have a structured schema for that. So we went with this key values approach where we should be able to support any type of data. Extreme performance, right? We talked about the volume and the variety of the data, the velocity of the data that comes from IoT devices, right? We need to scale to that extreme level of velocity. So for that, I think our writes have to have minimal throughput, right? Minimum latency with maximum throughput, right? I think I'll talk about that in the next slide, the KPIs that we have and how we were able to meet that KPIs with NoSQL. Built-in HA scalability. We need to have a system that is 24/7, 365 days, right? We cannot have zero downtime because of the number of devices that will be connected and all that one, right? The moment we lose connectivity and all that one, we can potentially lose data, and that might impact the forecast and the anomaly detection. Some of the other advantages are a little bit more intangible, like online maintenance management upgrade, right? And the Oracle NoSQL, the advantages are other. It's again you can have shards across different data centers that will give us a much more DR capabilities, even if a data center has some issues and all that one. So some of the features we talked about in the previous slide are very common to all NoSQL technologies, but how does Oracle NoSQL stand out? what are the specific features in Oracle NoSQL that we really got attracted to, right? Couple of things is, we, as we talked about that in the previous slide and before, we need to have something with very high velocity of data support, right? So we need something which is very fast write throughput with low latency. So our KPI was 10k messages per second, right? With the traditional databases, with all the ACID transactions and the commits and all that one, right? This is pretty hard to achieve, right? Right, of course I cannot say completely unachievable. We need to have achieve, but you need to have a very high hardware, powerful hardware, right? But with a low hardware, with a commodity hardware, with NoSQL, we should be able to achieve this number with a small set of shards. We talked about the data modeling, right? The other advantage is most of the IoT data time series data, right? So this gives an advantage the way NoSQL is modeled and all that one, the queries, by making that as part of the shard, that gives us the advantage, the shard key, right? We should be able to easily query the data based on the time zones and the time points. The other advantage we have with NoSQL is seamless integration with Elasticsearch, right? The latest version of NoSQL supports syncing up data with Elasticsearch. You can write it to NoSQL, it will do an automatic sync to Elasticsearch and make sure that the data is in sync. This gives us very flexible architecture where we can query either against NoSQL or with Elasticsearch, right? The other feature that we use heavily in IoT cloud services is the TTL feature. TTL stands for time to leave, right? As we talked about a couple of times by now, is we get huge amount of volume of data, right? So we need to be able to roll up the data, right? We cannot keep on accumulating the data forever, right? So we use this feature to sort of run the old data. The other great feature of NoSQL is uh, configurable durability and consistency, right? One advantage of this NoSQL is you should be able to set the durability levels on a per table level, right? So some of them we want to make sure that the data is synchronized across all the shards, not just the primary, but we want to make sure that it's replicated against secondary, right? Things like which is important critical data like alerts. Data that is not critical like regular raw data, you want that to be written faster, but you don't want to wait until it all the shards got replicated too. So you should be able to set on a table level on what kind of durability you want, what kind of consistency you want. This feature really helps us in differentiating the critical data versus non-critical data. How did we use NoSQL in IoT, right? So for us, we went with the replication factor of 3 for our DR. So we have 3 shards, one primary and one master and 2 slaves. And we save a lot of data in NoSQL, right? Not just the raw data that we get from devices, but more importantly, the analyzed data, right? The data that we get based on the analytics we do for predictions, anomalies, right? Annotated messages, incident, everything for us goes into NoSQL. All the message information we persist in NoSQL. On top of it, we do historical and roll-up data for predictive analysis, right? Again, all that information also goes into the NoSQL. And as I briefly mentioned earlier, right, we use the Elasticsearch backing of NoSQL feature, right? So the data that we write into NoSQL, some of the data, not all the data, is also replicated into Elasticsearch. That gives us with NoSQL as the source of truth. So that gives us the flexibility to query either against NoSQL or Elasticsearch. For faster and simple queries, we go against NoSQL. For advanced and complicated queries, we use Elasticsearch. So, but we don't have to worry about making sure that data is in sync between this thing. we put the onus on NoSQL for the data sync issue. And the other feature that we use is the TTL feature. We talked about that earlier, right? So we use both the table level as well as the row level features of TTL. We have defaults at the table level, but critical data can also, the row level TTL can also be employed for the critical data. One other great feature that really improved the performance of IoT is the bulk ports. Right, literally our the write throughput improved by 3x after this feature. Is bulk port. Instead of writing one row at a time, we batch and write to NoSQL. That really help because of the data we get is very humongous, and we sort of batch it and write it to NoSQL. That gave us a huge performance improvement. And the last thing I want to talk about is the usage of secondary indexes. As we know, secondary index is costly in NoSQL. So instead of using secondary indexes across the board, we use a hybrid approach. Cases where when the data is small, the tables are small, but we want fast queries, we use secondary indexes. But cases where the data is huge, the second instead of creating secondary indexes, we replicated the data. So that's all I have. Hopefully, this gives a good case study of how we used Oracle NoSQL and how we leverage NoSQL. Thank you.